Next presentation is from Andrae Harris, civil engineering background, supervised by Dr. Pradeep Behera. Application of oceanic sand as construction material to address sea level rise. So, Andre, can you share screen? Yeah. Yeah.
Good afternoon, everyone.
Good afternoon.
Hope you all are doing well. Hope you all are safe. As Dean Shetty pointed out, I'll be presenting on understanding marine properties and oceanic sand and using it as construction material. Just a second. Okay. So just before I get into the research, just want to say special thanks to the Lockheed Martin Fellowship for this opportunity. I learned a lot while under the tutelage of Dr. Behera. He really has a lot of information regarding the civil engineering aspect and a lot on this topic. He has been of huge help. Shout outs also to Mr. Pablo Sanchez, who has been a huge part of this research. He has helped me throughout each step. And yeah, just want to say special thanks to them. Special thanks to you all also for joining, and hope you learned something from this presentation today. So the statement of the problem. So we know that in our world, and it has always been an issue, climate change has been impacting our world. And this impact has really affected sea level rise in a negative. So sea level rise has become a very huge factor that we need to take consideration of, because it will cause very large disastrous impacts to our coastal communities, including key places such as New York and New Orleans. So we can expect those places to be having issues with water in probably 2050 as the sea level continues to rise due to climate change. Now, the need for the study. In order to protect these areas, we thought about building blockheads or walls in order to protect our coastal communities from the effects of sea level rise. So one of these methods was to use marine sand due to riverine sand, which is the usual material used for construction of cement or concrete, to use marine sand as an alternative, because riverine sand is being used up so much in all the different constructions, whether constructing new infrastructure, repairing infrastructure, or just preparing cement and so on. So in using marine sand, we're now trying to find if it will be just as effective as using riverine sand. So we know that marine sand has a lot of sodium chloride in it, which becomes corrosive and weaken metal. So this can cause very catastrophic, disasters if not treated and used properly. So this study really gets us to understand the properties of marine sand as construction material. So just to point out, this study doesn't account for all sand, because in some areas the concentration of sodium chloride can be different in certain areas. So it doesn't account for all marine sand, but we're hoping that this is a step in the right direction. Also, another limitation is it was not complete due to the coronavirus, and the labs were closed down, so we couldn't continue to do all the steps. But we have something here for you all today. Now, just a bit of recap. I'm not sure if all of you know, but just to point out to you guys. So according to Seth Schulman, from the Union of Concerned Scientists, global warming is the primary cause of sea level rise. So just to put that out there. So global warming is the primary cause for sea level rise. Due to the increase in the temperature, the large ice glaciers are melting, and that large volume of water is being added to our oceans. So imagine having a cup of water that is already filled to the brim or to the top, and then adding ice cubes to that. It does, the level of that water increases, right? So that is what is happening now as our ice glaciers melt. That volume of water is just being added to our oceans, causing it to rise. We can expect major cities and towns to be affected, if not completely destroyed, as a result. And in order to, combat the effects, we decided to construct walls using this marine sand. So let's get into it. So what have I done so far? I've retrieved the soil sample that we'll be using throughout this research. It was washed thoroughly, and in order to remove the salt, the ASTM standards were used and obtained in order to get precise results, accurate and precise results. Also, the C136 standard test method for sieve analysis of fine and coarse aggregates were also used. And I collected this data, plotted a graph, and analyzed it, and we'll get into that also. So this right here is just an outline, or just the standard, sorry, that was used to test the sieve analysis, and also to prepare each of the different samples that we used in this research. So for those who don't know what the setup would look like, these right here are the sieves. And as you go to your left, the sieves get smaller. So for each square inch, the sieve number increases. So for the first set, we have where you can see it would be stopping boulders. As it gets smaller, it stops smaller and smaller particles. So this is what we will use to separate the particles according to their size. So we can further understand the type of material that we're working with here. On the screen right now is the data that I collected. So to your right, is the data that I collected. Mainly the mass of the sieves, the mass when the soil was added to the sieve. So after the sieve analysis, so each sieve would be compiled upon each other, starting from the pan that would be collecting whatever would be passing through the finest sieve. So that would be sieve 200, moving up to larger sieves. So sieve number 8 would be the one that would be stopping the boulders, right from the example. So we found out the amount of soil being retained, the percentage of soil being retained, and the percentage of soil being passed. So being that we're using marine sand, we weren't trying to where we collected the sand wasn't with large boulders. So you can expect that most of the sand or the sample would pass through these larger sized sieves. So as we go down, you can see where less and less soil was passing through it. Below that, we have a graph that was plotted according to the percent of soil passing with the diameter. Now, this graph is showing that we have quite a large amount of sand passing through coarse sand, that is passing through our sieves between 8 and 10 thereabout, or 8 and 16. And as we continue to increase in sieve number size, we can see where less and less percentage of soil was passing through each sieve. Now, I want to thank Mr. Sanchez for the file. So the data was collected, placed into an Excel file, and this Excel file calculated most of these data that you're seeing in red. Now, conclusion, the marine sample, one, was extracted from the waterline. So this is close to the water. And this was proven by the fact that it had the coarsest grains. So the example of the data that I showed you just now was from my marine sample number one. Marine sample number 2 and 3 followed respectively. So how the soil was collected, and the data, which I will show you in a bit, continues to prove this. We collected from the shoreline and took 10 steps going from the shoreline inland. So, and then collected there and continued with another 10 steps, collected again. So we continued to use that method of collecting samples for each marine sample 1, 2, 3, and 4. We had a control sample, which was of riverine sand, to ensure that we were getting some results that were similar to riverine sand, which was the best material for construction. So it was noted that riverine sand and marine sample number one were the closest together. So we decided that marine sample number one would be used to test the strength now of this material. However, the test method C109, standard test method for compressive strength of hydraulic cement mortars, was unable to be carried out due to the outbreak because the labs were then closed. So we were unable to carry out this part of the lab. But it is expected that the marine sample number one will do a good job. If not, we'll continue to work on it to ensure that we have the best sample and the best results. So like I said, for future results, we aim to compare the strength of the concrete made with riverine sand and compare it with that of the concrete made from the marine sand, and then analyze these characteristics so that we can definitely have the best results. Here are just a few of my references.
Right.
So to show you the rest of the results, this is the final report, but I'll just go all the way down to the results. So this one was for, so I'll be showing you the graphs. This is for marine sample number one.
We're not able to see that on the screen.
Oh, I'm sorry. Just a second. How do I bring this up? So stop sharing and then start sharing again.
Oh, no. We almost have it there.
I'm sorry. Here we go.
Just share screen one usually works.
Okay. So to your left, this is for marine sample number one. Just to give you guys an idea of exactly what I got, what my results were. Right here we have marine sample number two, and you can see a very different graph. Here, between these 2 points, you can see that there was less passing through between sieve number 10 and 16. Now this is for sample number 3. And this is just to give you guys an idea of exactly what we were working with for results in this research.
So start the questions. Maybe like if you had a chance to do experimental work, you were like, how were you planning to proceed in the lab? Which machines would you have used? How you would have done it?
For the compressive strength.
Compressive strength. Yeah.
So I would be working with Mr. Sanchez.
Yeah.
So I'm pretty sure he would point me in the right direction as to which machines to use. As I said, we were not there as yet, but yeah.
You'll be using one of those punch presses,
Yes.
So any questions? So let me throw up, I think, any from the students or faculty members. I think there are a number of faculty members have joined. Well, hearing none, thank you. Thank you very much.
No problem. Thank you all very much.
Continue good success and hope to see Oceanic Sands in building construction,
Yes, sir. Yes, sir. All right. Thank you.
Okay, thank you.